Hi everyone, my name is Karthik and I'm a PhD student in the DGP lab at the University of Toronto. Today I'm presenting our work on task allocation for human-robot collaboration. In human-robot collaboration, humans and robots work together to achieve a common goal. One of the many challenges in HRC is determining what actions each member of the team should take, a problem known as task allocation. Prior work has proposed many solutions to task allocation. For instance, using offline or online planning methods, which prescribe what the human and the robot should work on during the task. However, sometimes it is hard to pre-plan all aspects of an HRC before the task commences, and humans may want to make changes to the task allocations in an ad hoc fashion. Hence, prior work has proposed behaviors that the robot can use to facilitate ad hoc collaboration. For example, the robot can respond to user instructions in a reactive manner, or the robot can infer allocations such as by picking up objects near its gripper in a proactive manner. We take inspiration from ad hoc HRC and coordination behaviors exhibited by human teams, such as the notion of territoriality and proxemics, and HCI work on designing interactions with proxemics in mind. Tabletop territoriality describes how collaborators distribute resources in the shared workspace while working on a task. Proxemic interaction states that we can exploit physical and spatial relationships with objects to enable fluent and natural interactions with them. In our work, we make two contributions: a design space of novel task allocation techniques for ad hoc HRC, and a comprehensive evaluation of the design space. We propose 3 new explicit techniques where allocation occurs through deliberate user action, and 3 new implicit techniques where the robot allocates objects to itself based on simple heuristics. Our first technique is called menu, where the user can touch or point at an object to bring up an allocation menu. The second technique is called subtle relocation, through which the user can push an object towards the robot to assign it. The last technique is called fixed territories, where the tabletop is divided into territories belonging to the user, the robot, and the group. Objects change allocation based on where they're located on the table. Our first implicit technique is called distance, where the robot allocates objects based on how far away they are from its base. The second technique is called gaze, where user gaze triggers territories which the robot avoids picking up objects from, and robot territories which it actively picks up objects from. And the last implicit technique, which is called proximity, where territories are formed when the user or the robot picks up objects from a region. Subsequently, the robot avoids picking up objects from the user's territory and only picks up objects from its own territory. We evaluated the techniques on a set of block stacking tasks where the user manipulated yellow blocks and the robot manipulated black blocks. We studied coupled tasks where the user and the robot had to place blocks alternatively to complete a structure, and decoupled tasks where the user and the robot could independently complete their own structures. We also studied object placement. Objects for the user and the robot could be scattered around the workspace, or they could be pre-sorted. Here are some clips from the user study. We found that implicit techniques led to faster task completion times, led to increased concurrent activity or simultaneous time spent by the user and the robot on the task, led to increased robot errors or incorrect allocations, led to an increased perception of being able to parallelize or work on the task and allocate objects simultaneously, and finally, led to a reduced perception of being in control over task allocation. Based on these findings, we think that future task allocation could be improved by building implicit allocation techniques with explicit control mechanisms. For example, in the proximity technique, the user's territory is implicitly formed when they pick up objects in the region, but the user could set the territory size explicitly. Thank you very much for your attention.